Welcome to this deep dive into, well, what might be the most defining competition of our time, the US-China AI rivalry. We're seeing two really fundamentally different playbooks emerge.
Yeah.
You've got one side betting billions on these huge generalized supermodels, kind of hoping for a miracle breakthrough, right?
Yep.
And then the other side is shipping vertical products, things that actually work and generate cash now. If either approach really cracks the winning formula first, well, your startup, your supply chain, maybe even your job, you're going to feel it immediately.
Right.
We've been looking into this, thinking about the shift from chips to power, the difference between this enlightenment idea versus incremental mastery,
Yeah.
and just the surprising reality of who's actually making money from AI right now. Let's unpack it.
Yeah, and it's crucial to understand both countries absolutely see this as, generation defining. This is critical. Remember maybe 10 years ago, the big things were 5G and AI?
Yep.
And you could argue the US has sort of lagged a bit in 5G, but right now they definitely seem to hold the lead in that frontier AI research. A lot of that comes down to their edge in cutting-edge hardware and just the sheer scale of those initial large models they built.
Okay, so a lead today,
Yeah.
but it's built on a very specific strategy for winning the long game, isn't it? Let's dive into that difference. The US path, people call it the enlightenment strategy.
Exactly. That term captures it pretty well. It's almost entirely focused on chasing superintelligence through these massive, generalized, large language models. In Chinese culture, there's this concept, Starga. It translates roughly to cultivating immortality.
Cultivating immortality. Wow, that sounds incredibly high stakes.
It absolutely is. The core belief in the US approach is that there's a specific single breakthrough moment, a singularity, or like instant enlightenment. The idea is if an AI suddenly achieves self-awareness, it'll instantly teach itself, compressing like decades of human learning into seconds, superhuman performance across everything.
So the entire strategy, the hope for winning this whole rivalry, just hinges on hitting that one magic moment first. Get that enlightenment and game over.
That's the bet. If that technological leap happens, the race is effectively finished. You pour money into bigger and bigger models until, bang, singularity, then the economic payoff is almost infinite.
Okay, but that's in stark contrast to China's strategy, right? The AI plus or Krasima approach, more bottom up.
Precisely. The Chinese approach is more like mastering 18 different weapons or tools. They aren't really waiting for some godlike AI to appear. They're focused on narrow vertical applications, stuff that solves actual real-world problems right now and, crucially, generates immediate cash flow. Think about it. Why wait potentially hundreds of years for a general AI that writes poetry and manages logistics when you can build a super effective factory vision system today? That system improves efficiency, you charge clients for it, and it starts generating valuable data straight away.
That's a huge difference. Potential versus utility. And what's really interesting is the strategic angle. Even when Chinese companies do work on bigger models, the US seems to be locking theirs down, right? Closed proprietary system.
Yeah, increasingly so. Whereas China is making a calculated gamble, committing pretty heavily to open source models, even their powerful foundational ones. This looks like a deliberate strategy to, well, deconstruct the US monopoly. If you offer a powerful open source model for free, you encourage developers, startups, even whole countries all over the world to build their stuff on your foundation.
The old rural areas surrounding the cities strategy. You're not just selling a product, you're building this massive decentralized ecosystem that depends on your framework.
Yeah.
That's a really smart long-term political and economic move.
It is, especially when you think about the long-term value of data, which we should definitely get into later.
Okay, right. Let's look at the money then. Because all this talk of singularity, it feels very reminiscent of the dot-com bubble, doesn't it? 1999, 2000, you see huge amounts of capital, tons of talent flooding in, but actual profitability, the part where tech turns into real revenue, it seems way behind the hype, behind the valuations.
That's the tough reality check right now. Outside of the hardware guys, many US AI companies are frankly struggling to show clear profitability. We're even hearing from firms that in some real-world coding tasks, the overall efficiency of using an AI is currently lower than just using a traditional human coder.
So the machine is slower, or costs more to run, or needs more human oversight than the person it's meant to replace.
Exactly. You factor in the cost of running the model, fixing its errors, all the infrastructure. It just eats away at the supposed efficiency gains. You end up with huge investments chasing pretty limited real-world results so far.
So if we stick with the gold rush analogy, the only people guaranteed to make money are the ones selling the shovels, NVIDIA, AMD, the hardware folks. But even there, you mentioned signs of maybe overheating. bubble behavior.
Yeah, we are seeing some classic signs, that things you see late in a potential bubble, particularly around capital self-dealing. Like, imagine a VC firm. They have stakes in a chip maker and an AI startup. They give funding to the startup. And what's the first big thing the startup does? It buys huge amounts of chips from the manufacturer the VC also owns.
So it's basically using funding to create this closed loop. It looks like massive demand for chips, but really, it's capital just circulating between related companies to pump up valuations and justify the narrative.
It creates a sort of artificial demand floor that might not be sustainable if it's not backed by genuine paying customers using the AI profitably. And this whole situation points to maybe the ultimate hurdle for that U.S. Enlightenment approach, just raw compute power.
Can we actually get to that instant enlightenment, that singularity, with the tech we have now, or even in the near future?
Well, some serious analyses are suggesting that reaching that level of, conscious general superintelligence, it might just be impossible without a massive breakthrough in quantum computing. And if that's true, then the current U.S. path, betting everything on a quick singularity, might actually need something like 300 years of slow, steady progress using our current silicon technology.
300
Yeah.
years. Okay, so that changes things. The promise of a rapid breakthrough isn't really a strategy then. It's more like investment comfort, a story you tell.
It could be seen that way. Because if the U.S. does need 300 years of incremental steps, well, they lose that big strategic advantage over China's vertical AI approach, which is already mastering incremental progress.
Right. In contrast, those Chinese vertical AI companies, the factory robots, the fancy coffee machines, whatever they're designed from day one for profitability, for cash flow. They charge clients for solutions that work now, and their growth isn't totally dependent on some future vaporware story for VCs.
Exactly. They're making money today, and at the same time, they're trying to keep pace in the general model race using clever algorithms. They're building on a solid economic foundation.
This focus shift, away from software promises to hard fiscal limits, brings us right to the infrastructure battle. For years, it was all about chips, right? The U.S. used its chip advantage to restrict China. How's that looking now?
Well, that initial advantage, while it definitely had an impact early on, it also, perhaps ironically, really spurred China to develop its own domestic alternatives much faster. And the proof that things have shifted is China recently refusing certain high-end NVIDIA chips.
Why would they refuse them? Wouldn't they want the best?
Well, refusing them signals confidence. It suggests they believe their own domestic supply chains are now good enough to support their internal AI development at the scale they need. It feels like we've moved past the U.S. having a critical chokehold on chips. We're probably in more of a chip strategic stalemate now.
Okay, so if chips are stalemated, what's the next big bottleneck, the constraint everyone's going to bump up against? There's talk that it might be something much more basic, like electricity.
This could be the absolute crucial point going forward. These giant data centers training and running the big AI models, they consume unbelievable amounts of power. We're talking the energy needs of small cities for each one, and the U.S. power grid. Well, its growth has been notoriously slow for years. We've got regulatory hurdles, local opposition to new lines, just aging infrastructure that's really hard and expensive to upgrade.
So the grand vision of running super AI in the US might hit a wall, not because of lack of money or chips, but literally because you can't plug the darn things in.
That's the emerging concern, and it leads to this potential geopolitical energy trap. Let's say the US pushes hard for clean energy, solar, wind, battery storage to power all these new data centers. Where does a lot of that technology, especially batteries and solar panels, come from?
China. They dominate global production in new energy tech.
Exactly. So you could end up in a situation where China could potentially throttle U.S. computing power and therefore the ultimate scale of U.S. AI, not through silicon chips, but by controlling the energy supply chain, leveraged through batteries and panels.
Wow. That completely flips the script, doesn't it? The strategic battle moves from complex semiconductors, where the U.S. had the edge, down to basic power generation and storage, where China has built up massive global manufacturing scale.
It potentially shifts the entire strategic balance.
That's a really sobering thought for anyone building a company right now. Maybe founders should worry less about the next chip announcement and more about where their kilowatt hours are actually going to come from. Okay, let's pivot slightly. What are the lessons here for builders, for founders around the world? China, you mentioned, is using smart algorithms, companies like DeepSeek, to try and compensate for any hardware gap they still have. How big a deal is that algorithmic side?
It's significant. It means finding clever, more efficient ways to train and run these models using less raw compute. But the talent needed for that kind of innovation, that's become the focus of an incredibly intense global war. And the US is consciously using a massive brain drain strategy here.
Brain drain.
Yeah, think about the salaries US tech giants are throwing at top AI researchers, signing bonuses over $100 million in some cases. It's hard to even grasp. One analysis compared these AI talent deals not just to top sports contracts, but almost to state-level defense spending. That's the perceived strategic value.
So it's a deliberate strategy to hoover up the best minds, weakening competitors by pulling their top talent westward. But that kind of intense competition must have downsides too, right? There's this idea of involution.
No one, yes. It describes this destructive zero-sum internal race where everyone works harder and harder, but the overall results don't actually improve much or even get worse. When you pay a few engineers $100 million bonuses, it creates immense internal pressure, jealousy, burnout. It can misallocate resources across the whole organization without necessarily leading to better outcomes.
So it kind of eats away at the health of the US tech firms internally, even while they're winning the immediate bidding war for talent. But maybe the ultimate prize isn't just the top 100 researchers, it's the data, right? The data from the 6 billion people living outside the US and China.
That's absolutely critical. China seems to understand this deeply, the need to include the rest of the world. Platform value grows exponentially with users, and data is the fuel for the next AI breakthroughs. So what are they doing? They're using state subsidies, low-cost strategies, sometimes even giving away foundational AI products for free. Things like logistics software, smart home tech, basic medical diagnostics tools, aiming for rapid market penetration globally.
It sounds like they're trying to repeat their manufacturing playbook. They caused a global price revolution with cheap smartphones, affordable solar panels, especially in places like Africa and Latin America. Now they want to do the same thing with AI tools.
That seems to be the strategy. Get the tools out there, make them accessible and affordable. The mindset is build first, optimize later. Prioritize getting the maximum amount of global data flowing into your platforms, even if it means lower margins initially. Because if you capture that data first, your platform's value could skyrocket, even if you haven't hit some magic singularity.
Looking even further ahead, this whole technological race is obviously going to reshape society in fundamental ways. We have to talk about the impact on jobs. This is the big question for everyone listening, isn't it?
Yeah, and the crucial point that comes up again and again is that this time feels different. Previous industrial revolutions shifted jobs, right? Carriage drivers became taxi drivers. But AI seems poised to eliminate huge numbers of jobs entirely. And not just blue-collar jobs, but white-collar roles in creative fields, highly trained engineers, STEM fields. It touches almost everything. And even the idea that we'll need people to build and maintain the robots. Well, what if the robots can automate that too?
Which means that accumulating knowledge, like getting an expensive university degree, might rapidly lose its value. Why spend years learning something if the AI can access, synthesize, and generate perfect information instantly?
Exactly. The skills that remain uniquely valuable might be purely human ones. Emotional connection, complex social interaction, maybe certain kinds of abstract creativity that AI can't replicate. And in that kind of world, having a job, it stops being a basic economic right and becomes almost a scarcity, a privilege that gives you purpose, structure, social connection.
The social consequences of that are profound. You could see society splitting into two distinct groups, maybe permanently. Those who own and control the AI, potentially living longer, healthier, smarter lives, and those who are essentially managed by the AI, maybe poorer, less informed, perhaps spending more time in virtual realities provided for them.
It's a stark possibility. And it puts immense pressure on political systems globally. How do you manage that kind of radical inequality? You have the US model, bottom-up liberty, fierce competition, and you have China's model, top-down control, focused on stability. Which system is better equipped to handle the extreme concentration of wealth and power that AI could create? That is a huge and, frankly, quite frightening open question. So this competition between the two paths, the vertical, profitable craftsman versus the generalized, maybe bubble-driven visionary, it's going to shape so much of the next century, economically and socially.
So, thinking about the key takeaway, if the U.S. singularity dream is possibly limited by physics, by energy, and China's craftsman approach is maybe limited by this talent drain, where's the real leverage point? Is the ultimate bottleneck infrastructure, like power? Or is it really about winning that global war for talent, algorithms, and crucially, data?
That's really the core question to ponder, isn't it? How does your own business, your own strategy hold up if energy becomes the main constraint on compute power, no matter who has the cleverest algorithm?
If you're sourcing from China, maybe building AI tools for logistics, or just curious about piloting something in the Chinese market, drop China AI pilot in the comments. Tell us your industry and just one line about your challenge.
And subscribe to China Gateway for more of these grounded conversations on tech, trade, and transformation.
You've been listening to this deep dive. Thanks for joining us, and we'll see you next time.